So in my section, we're gonna be talking about circuits. So so one of the key things that to make a computer work is through certain key components such as circuits. A circuit is essentially a connection of electrical components that process signals. There are two main types of circuits: analog and digital. Analog circuits process continuous signals, but digital circuits work with signals that are represented by discrete values. These values are things like zeros and ones. Digital circuits are the foundation of how a lot of computers work, and they are built using logic gates, which perform operations such as and, or not. When describing circuits, one of the key ones we'll be talking about is combinational circuits. One of the ways to do this is by using a truth table. A truth table simply lists all possible input combinations and their corresponding output values for a circuit. This makes it easy to understand how a circuit behaves with different inputs. So another way we could conceptualize a combinational circuit or describe the behavior of the circuit is by using Boolean equations. A Boolean equation uses symbols to represent logical operations. Such logical symbols are things like ands, which represent multiplication, or for addition, and not for negation. These symbols help express the relationship between the inputs and outputs of a circuit in a way that can be easily converted into a digital circuit. So another key part of circuits is multiplexers. So what are multiplexers? A mux is a circuit that selects one of multiple inputs and passes it to a single output. The mux uses a control signal to determine which input gets passed through the input. So an analogy of how multiplexers how they operate is thinking of it as a traffic lanes, where a person dictates which ones of those traffic lanes go first, or which ones of the people who go first in those traffic lanes. Next, we'll talk about sequential circuits. These circuits need to handle both present and past values. So how do they operate? They use things called registers. A register is a circuit that stores a certain number of bits and can update them based on control signals. An example of this would be an n-bit register, which stores n bits of data. These registers update their values with when a clock input rises. Basically, what a clock is that it keeps all the registers synchronized. So how does a computer execute instructions? It does this through a thing called its processor. The processor is responsible for executing a series of instructions. One of the key processors designs are MPIC is a simplified version of MPIS and has key components that allow it to perform its tasks. These include instruction IM, and which stores the instruction for the processor to execute, and data memory M, which holds the data the processor works with. And finally, the register file, which stores the processor's registers, which holds temporary data finally, and tracks the address and the current instruction to the execute. All right, that's all for my section right here.